Hello everyone, I'm Mur Jayapadma, a first year PhD student in the Special Educational Program on River Basin and Environmental Science. So I'll be presenting you about my research on assessing the flood risk using machine learning integrated with physically based model output. So this is the basic presentation outline, and as you may all know, climate change is affecting the world in various aspects, and as per the latest reports, the annual and summer monsoon precipitation all over the world is going to increase significantly. And as a result, the damages to infrastructure due to floods is also going to increase significantly across the globe. And as you could see in this figure, the areas in green that includes developing Asian and African countries are the most vulnerable areas to those heavy precipitation extremes predicted. And on top of that, it is being reported that some sort of flooding is seen in more than one third of the world's land, where more than 82% of the world's population reside. So I think it's quite obvious how important it is to study about floods and also to study about the impacts of climate change on floods to seek for effective adaptation measures. So I chose the Ging River Basin in Sri Lanka for my study. As you may all know, Sri Lanka is an island located in the Indian Ocean, and the river basin I chose for my study is located in the southwestern part of the island. And why I chose this river basin for my study is that this river basin has been subjected to frequent flooding in the recent past. And from a previous study I conducted in this river basin, I developed a flood model using the physically based rainfall runoff inundation model, which is also known as RRI model. And I developed a flood model that simulated the future river flow, including the flood flow and the inundation area corresponding to future climate change scenarios. And from that study, I could see that the monsoon rainfall received by the basin is going to increase significantly by almost 10%. And also the high flows in the basin is also to increase by 10%. And as a result, the inundated area in the basin due to floods is also going to increase by almost 3.5%. So these results further stresses the requirement for detailed and accurate flood risk assessment to seek for effective adaptation measures. So I thought of using machine learning models and to integrate with physically based model outputs to assess the flood risk in the basin accurately. And speaking about machine learning, as you may all know, machine learning is kind of training a computer system with a lot of observational data and making it learn by itself and making it improve and extend by itself without being programmed with that knowledge. So these kind of data driven models are being widely used in the field of climate change risk assessment. But these studies are mostly limited to nowcasting, or they are only used to predict properties that are quite static over a short observational time period. And also the machine learning models are computationally expensive, and also the interpretability is also a big disadvantage of using the data driven models for these kind of assessments alone. So my scope, my aim is to fuse the physically based model outputs I obtained from the previous study and to use suitable machine learning methods so that I can obtain more understandable and accurate flood risk assessments for the basin so that we could implement proper flood mitigation measures. So this is the basic scope of my study. As I said earlier, I'll be fusing the inundation depths and the areas I obtain from the physically based model outputs. Then I'll be selecting suitable machine learning methods to model the flood susceptibility and then the flood hazard in the basin, exposure, vulnerability, and finally to model the flood risk assessment, flood risk in the basin. So these are the objectives I'm going to achieve in my study, and this is the methodology I'm to adopt to achieve those objectives. As I explained earlier, I'll be using the physically based model outputs, and along with that, I'll be using suitable machine learning methods to model the flood risk in the basin. So this is the basic idea of my research. I hope you got an idea about it, and thank you very much for your attention.